Welcome back. Now we want to do problem 2. In the problem 2, we had a beam that was subjected to distributed loads. As you see, we have two distributed loads. One is even, the other one is not even. Okay? And then the idea is to find the magnitude and location of the resultant of this distributed load with respect to point A. Remember it says with respect to point A. So when you want to calculate the moment or summation of moment, it should be about point A. So let's do Ry first. Ry means the resultant of forces in y direction. What is Ry? Summation of all forces in y direction, right? So what do we have? We have this one. This is a rectangle. So in the rectangle, how we can find the distributed load? We want to find one force from the distributed load. So you need to calculate the area, right? So this one, the side, this side length is 200. Now this side is 5, right? Area is going to be 200 times 5, and it's going to be in the center, right? We said it. The rectangle is easy. This, the force that you calculate, you have to place it in the center of the rectangle. So it's going to be right at this point 2.5 meter. And because the force is going to go down, so that was our rules. Force, this is positive, right? This is this x direction, this is positive, because as it is if going down, so we should put a negative sign, right? So this is the first load. How about this triangle? Again, you need to calculate the area. So this portion is 300, and this portion is 3 meter. So minus, because it's going to be down, 300 times 3 meter. Again, it is triangle, so you have to multiply it by half. So that is going to be 1.5. So this is 1000, this is a 450. Total will be 1450 Newton, right? This is the result. Next step. So where should we put this force? The resultant force will be in the triangle. We said it. It's gonna be uh, 1/3 of the L. This length. This length is 3 meters. So 1/3 of that length will be 1. So the force will be 1 meter away from this side. Okay. So that is the location of the distributed load of the triangle. Next step is to calculate moment summation about point A. What do we have? We have only two forces. So force 1 is this one, 200 times 5, and that is located 2.5 meter away from A. So F times D, that is going to be the moment, because it is making clockwise rotation, so we should show it with negative sign. So 200 times 5, that is the force 1000. What is the distance? D is 2.5 meter. So that takes care of the first force. The second force is from the triangle, that is 1 meter away from point B. That means if you want to calculate the total distance, so let me erase this area so you have a better idea. This is going to be the total distance. 5 plus 4 plus so we have to deduct 3, 1 from 3, so this is going to be 2. So the distance will be 11, correct? So what was how much was the force? The force was this, 450 times distance, 11, that will give you minus 7,000 450 Newton meter. Oops. So that's moment. The next step is to find the summation, the location of the resultant. X bar, right? The X bar is going to show the location. MA divided by RY. So we have both of them. This is minus 7,450 divided by this one for 1450. That gives you a positive value, 5.13 meter. What does it mean? So it means with respect to point A, the resultant is going to be this much away, right? 5 meter. So this is RY. Let me write it again. Okay, so that is the location of RY. So here is the answer, right? We got this one. This is important, and this one was important.